Hello, my name is Karen, and I'm going to give you a quick guide to our amperometric hydrogen microsensors. This guide will focus on the most important measuring characteristics of the hydrogen sensor. If you would like in-depth information and details about Unisen's hydrogen sensors, please see the lecture about Unisen's amperometric microsensors. This is a photo of hydrogen sensors in action. We make them with different cables and connectors so they can be applied both in the lab and in the field, including shallow and deep sea applications. This is a schematic drawing of a hydrogen sensor. It consists of a tapered glass casing, a gas-permeable silicone membrane, a working platinum electrode, and a reference electrode. The working electrode is polarized against the internal reference electrode. Hydrogen diffuses through the tip membrane to the working electrode, where it is oxidized on the positively polarized working electrode. A current is generated, which can be related to the hydrogen gas partial pressure. All of these electrodes are submerged in electrolyte for balancing charges. The current that is generated is very small, and we only guarantee the performance of the sensors when using Unisen's amplifiers. Detailed specifications for our hydrogen sensors can be found on our homepage. I will, however, elaborate on a few of the most important sensor specifications. Unisen's microsensors are handmade, and our skilled technicians can customize sensors to obtain the best possible characteristics and design to your specific application. The model name indicates the sensor type and tip size, meaning that a H250 is a hydrogen sensor with a 50 micrometer tip. We produce them with standard tip diameters from 10 to 500 micrometers, but we can customize them to tip sizes between 3 and 800 micrometers. Besides the tip size, we can also customize the design of the tip to be more or less slender, as well as the body length and shape. Please consult our tip selection guide to get more information about choosing the right tip size for your application. The sensitivity is strongly influenced by the experimental design, but a standard hydrogen sensor has a detection limit of 0.3 micromolar. We do, however, make the larger versions with a detection limit of 50 nanomolar. A hydrogen sensor responds very fast to changes in hydrogen partial pressure. The smallest of the sensors have a 90% response time of less than 10 seconds, whereas the larger versions have a response time less than 30 seconds. We can modify and adapt our hydrogen sensors in many ways, making them useful for a broad range of applications. The hydrogen sensors can be mounted in needles to protect the fragile glass sensor. The needle sensors can be produced with different needle diameters and length. You can see the specifications for the needle sensors on our homepage. The most robust needle version is the H2NP, which is this one, and it is made for penetrating stoppers. These needle sensors can also be manufactured in the low-range version with a 50 nanomolar detection limit. The sensors can also be mounted in protection cap to protect the fragile sensor tip for bulk measurements in larger samples. The sensors for the microrespiration system is mounted in guides that allows for easy insertion into the microrespiration chambers without contaminating the samples. The sensor body can also be made of steel with threads, so it can be screwed into pipe systems or incubators. The sensors can also be mounted in flow cells, and we have both these glass flow cells as well as pressure tolerance wage lock steel flow cells and these P flow cells like this one. In general, if you have any special requests regarding adaptations, please do not hesitate to contact us. We will be happy to help you find the right solution for your specific application. Thank you for watching this Unisense microsensor lecture. I hope you enjoyed it. If you have any questions, you're more than welcome to contact us at sales@unisense.com.